Okay, so write down phi x, phi y, sx, sy in each of the examples below in terms of time t. So, unlike the last question, okay, what we've dealt with until now is horizontal projectiles. And in horizontal projectiles, when you throw a projectile up and down again, you have sx is the distance along the x-axis, sy is your distance into the air at any given point, phi x is your speed going to the right in any given instance, phi y is your speed going up or down in any instance. Okay? And throwing it up a hill, it's different. Okay, so we're actually going to redefine what phi x and phi y means, what sx and sy means. Okay, so what we're going to do this time around is you're going to have your standard xy axis. However, you're going to have a plane like this, and what you're doing is you're throwing the object up the plane like so, and it hits somewhere down here. So in order to combat this, what we do is we now redefine what sx is. Sx is now the distance not along the x-axis but along the slope of the plane. So that'll be an sx distance. Sy is perpendicular to the plane. It's no longer parallel with the y-axis. It's perpendicular to the plane. Likewise, phi x is going along the plane, and phi y is going either directly up or directly down relative to the plane. Is that alright so far? Yeah. Okay. Alright, let's just give it. Alright. So, what we're going to do first is we're going to use the same formulas as last time. We're going to use V equals U plus AT, and we're also going to use S equals UT plus a half AT squared. Now, we're going to do over here, just going to get rid of this gibberish for a minute, and we're back to our diagram. Now, what does it say about the angle of the plane? The angle of the plane is?
Beta. Beta. The angle of the plane
is at beta to the horizontal. So fair enough, right? Beta. Okay. That's alpha, and that's beta. Okay. Now, the difference between this one and the previous one is that gravity now acts against. It acts in two ways. It acts along the x-axis and it acts along the sy-axis. It acts against both of them. Here's what I always do to do gravity, okay? Gravity always has to go directly down, correct? So what we're going to do is, I always, don't have this learned off, I understand it. So, gravity goes straight down, and I always draw it in the middle of my plane. You happy with that? Then I draw another line, or starting from down here, I draw this other line going parallel to the plane. So this other line will go this direction here, parallel to the plane, roughly. Then I draw a third line that goes perpendicular to the plane. Okay? Now I do that a lot smaller usually, but just sort of stand the point home here. Now, can anybody tell me what angle is this here? Anybody in class know what angle it is? It's either alpha or beta. Which one do you think it is?
Beta.
Beta, alright, but we have to figure out why is it beta. Okay? So, using this triangle here, which I'm going to colour in yellow, eventually you get so good at this that you eventually don't need to spell it out so much, okay? If that one's beta, this one here is 90 degrees. Would you agree with that? The one on top is 90 minus beta. Then if you look at the green angle I'm about to shade in here, that's a right angle triangle, isn't it? That's right angle, isn't it? Which makes this angle here beta. That makes sense? Now, don't just learn it off as, oh, it's always the same as the incline, because they have tricks that stop you from doing that. Okay? So you got to be able to draw your triangle and understand where it comes from. Now that we have that, I'm going to work exclusively on this triangle here. Everybody happy with that? That triangle there? Now, once I have that triangle there, what's going to happen is the two things. We're going to have gravity is the hypotenuse, because gravity acts directly downwards. Can anybody tell me what component is this one here that I'm shading in blue at the moment? It's the adjacent side, isn't it? And the adjacent side is G cos whatever the angle is, B. And this one here that's in red, anybody? G sine B. Now, what this diagram has done in effect it's broken up gravity into two parts. It's broken up gravity into a part that is it broke up gravity into a part that is going along the SX axis and a part that's going along the SY axis. Is that right? So now we're going to put this into our equations. We're going to start off with Vx. Now, to start off with Vx, we also need to know what u is. So we have to go along to u as well, and we have to examine the angle alpha. So, u is being thrown off speed u, and it has two components. Okay? Technically this full diagram is rotated so that it's in line with that. Okay? But still 90 degrees when compared to the plane. So what are my two components for opposite and adjacent? Anybody tell me what the opposite is? U sine alpha. The best way to remember is the sine is opposite over adjacent, opposite over hypotenuse. So if you're talking about opposite, it's sine. If you're talking about adjacent, it's cos. So U cos alpha. You happy enough with that? Now, using this information, I'm now going to create phi x and phi y. And I'm going to get rid of the diagram in the top right as well. Okay, so what's going to happen is we're going to get phi x equals, what's the component along the x-axis for u? Or the component along the s direction for u? U cos alpha this time around. Now, what part of gravity acts against the x-axis? See, we're going this way. However, gravity is going that way. So therefore it's being taken away from it. So it's going to be minus G sine B multiplied by time. Gravity times time. Now you'll see me in all my solutions is I don't like the t beside the angle, so I always put it in here. Minus GT sine B. Okay? Phi y, anybody? What's the u value going along the y direction? U sine alpha. And what's the gravity acting against y? This one here, G cos B. So it's minus GT cos B. Now we've done the phi value, which is now used up. What about Sx and Sy? So S equals ut plus a half at squared. What's the u direction along the x? U direction along x, anybody? U direction along x? U cos alpha. So ut cos alpha, because it's u times t. The gravity plus a half at squared. So it's going to be, I'll just spell it out here, a half. What's the gravity? What gravity acts against the x again? G sine B. Now it's minus G sine B because it's acting against it. I'm quickly going to change this up a little bit. It's going to be minus GT squared sine B is the way I'll have that put down. Minus GT squared sine B. It always goes cos sine, sine cos, or cos sine. They always change. That always happens, okay? What about Sy, lads? It's going to be ut sine alpha, because that's the u value going in the y direction. and then minus a half gt squared. Which one is it this time? Cos, because cos is acting downwards. Okay? So cos b. And that there is your generic 4 equations, and you got to be able to make them every time. Is that right? We're going to need to try another one of them. Okay? Or you're going to have to go over this one again, and maybe 2 or 3 times before you get it. You might need to do this question at least another 2 or 3 times before it really sinks in. Okay? Next one, okay? This one here is different. In the first one, when you throw a particle up the hill, okay? So when you throw a particle up a hill, gravity slows it up. Like gravity along the x direction, this is the so-called phi x direction. If you're thrown up a hill, what gravity does is it slows up phi x because you're thrown up the hill. However, this time, you're throwing it down a hill, which means that phi x is actually going to be increased, not decreased. Okay? So also what's going to revolve is it's just a change in sign. It's not going to be minus gravity anymore. It's going to be plus gravity in the x direction only. So let me show you what we're going to do here. Once again, I'm going to start by drawing my plane. Just going to start with the plane as well. And then this plane here is angle beta. Once again, like last time, we're going to construct a triangle. There we look, this is the important part. We're going to construct a triangle going directly down. What does this line directly down represent? Represents gravity going directly down. Okay? Now, once I do that, what am I doing next again? Oh yeah. Parallel and perpendicular. Okay? So, I go to the point at which this line hits the axis. I can draw one going perpendicular, which is over here, yeah? And then I draw one going parallel. And then I have my diagram I have my gravity triangle, as I call it. I call it the gravity triangle. Okay? Now, this gravity triangle, using the same logic as last time, 90 degrees, 90 minus beta. Therefore, this one here has to be beta, because it's this here is 90 degrees. Works every time. Now that I know that, this one here is going, remember, gravity goes directly down. And remember the vector rule? Vector rule is that if you have a vector C going in this direction, vector A will have to go this way and vector B will have to go this way, so that your start and finish is the same. That's called the triangle rule for vectors. Okay? So in this case, gravity starts here and ends here. This means that this direction has to be going this way and this direction has to be going this way to bring in. It's like taking 2 roads instead of 1. Okay? It's the way to remember it. Now that we've done that, we know that this side here, which I'm now going to mark in blue, this side is the adjacent. So what does that make it? G, cos or sine? Cos. The other one is the opposite, which makes it G sine B. Okay? That's probably what most students consider the hardest part done. Next thing, we're looking at this u value being thrown in this direction here. We're going to make a right angle triangle out of that part there. And what do we get this time around? We have u going up here. What's that make the adjacent side? U cos alpha. And what's that make the opposite? U cos alpha. U cos alpha, U sin alpha. Okay, now that you've done that, we're going to go into our equations. Phi equals u plus at, and s equals ut plus a half at squared. So, let's begin with phi x and phi y. Somebody indulge me. What do you think phi x is going to be? Somebody indulge me. What do you think phi x is going to be?
U cos alpha minus gt.
Now, u cos alpha, you're right about that. it's going to be plus this time because gravity is making it faster because it's going in the same direction as your throw. So it's going to be making it faster. So it's going to be plus GT. So acceleration times time. And you got to remember, you got to put your angle onto it as well. So sine B. Now, what about Phi? Somebody take a go at Phi, please.
U sine alpha.
Okay, U sine alpha, yeah.
GT plus T.
It's going to be minus, alright? Now I'll tell you why it's minus. Although it's speeding it up along the x direction. See the way this line here is going in the same direction as your throw? However, gravity is still acting directly downwards, pushing it into the plane along the y direction. Okay? So that means that's going to be minus GT cos B. Alright? Now, what about SX and SY? Once you have the phi x, phi y, it gets very easy. This is the way I think of it. Just add a t onto phi x, so you're going to get ut cos alpha, and then it's a half gt squared, right? The difference between at and a half at squared, half it and add on a t squared. So I just half this value here, it's going to be a half gt sine b, and then I remember that the difference between the two of them is a t and a t squared, so I'll just add the t squared there, half gt squared sine b. You get really fast at it. What about the sy, guys? Anybody tell me what the sy equation is? Ut sine alpha, yeah. After that? Minus a half. Been able to make these guys, believe it or not, it's a pass mark in this question. Just been able to make them. Like, if you, what they're doing this time is they are, it's the same as last time regards, I'm gonna do gravity a bit quicker this time, alright? So what I do in the leaving cert is I usually do this. I draw straight down, I draw a parallel straight across, and then I draw my line going straight up. I have my gravity triangle drawn immediately. I go, okay, your theta, you've already proved that it's going to be the same as the angle of the wedge several times already. That's gravity. You're the adjacent side, so you're g cos theta. You're the opposite side, so that makes you g sine theta. Everybody happy with that? Now, the tricky part comes in that it doesn't give me the full angle for you. In the previous questions, it always told me the full angle for you. Can anybody tell me the full angle for you this time?
Alpha plus theta.
Alpha plus theta. How did you know that? Alternate angles.
Yeah.
Okay, is what you're trying to go for. Now, alternate angles being this one to this one, and then you can see a Z there. That's your alternate angle. So, what we're going to say this time around is that it's now theta plus alpha. Now, you've done your gravity triangle to perfection. Guys, try and stay awake if you can. Alright. The next one is your U triangle. And it's going to be theta plus alpha. It's going to be U. So what does that make the adjacent side? And we know the adjacent side? Other one? Okay. And now we're on automatic. We're just going to go for phi x, we're going to go for phi y, we're going to go for sx, and we're going for sy. Okay, let's try this out. U plus at, guys. Are we accelerating down the hill or are we slowing down? Accelerating down the hill. So it's going to be U cos theta plus alpha in brackets, and then plus gt. So G, is this G sine or G cos? G sine, because that's going in the same direction as the x direction. So gt sine theta. Always the opposite of the first one. The next one, U sine theta plus alpha minus theta. It's O, and then the next one, Sx. Remember, phi equals u plus at.
ut cos plus alpha.
So the extra part is the t, the squared, and the half.
ut cos plus alpha.
Ut cos theta plus alpha
Plus
plus a half
gt squared.
sine theta. The next part then, the sy. Ut sine theta plus alpha
Minus
minus a half gt squared, which one?
cos.
Cos. Okay.